Hello everyone. Today I am going to talk about a very interesting topic called CNN image super resolution. In simple words, this is a deep learning method that takes a low quality image and make it look clear and sharper. Sometimes you may zoom into a photo and it become blur. With super resolution, we use neural networks to recover detail and improve that image. We use tools like Python, Keras, and TensorFlow to build this model. The problem statements. Let's understand the main problem first. Low resolution image looks blurry, pixelated, and unpleasant. They are usually okay for small devices but not good for printing or using in designs. On the other hand, high resolution images are clear, detailed, and comfortable to look at. They are suitable for printing, zooming, and using in presentation. Traditional methods like bicubic interpolation just stretch the image and often cause rough edges. Deep learning can do better. It learns patterns from many images and tries to guess or recreate missing details. The autoencoder architecture. Now let's talk about how our model works. We use something called as autoencoder. It has three important parts. Encoder. It takes a low resolution input and compresses or shrinks it into a smaller representation. Bottleneck. This is a middle part where the most important features are sorted. It forces the model to focus only on useful information. Third, decoder. This part expands the compressed data and recreates a high resolution output. So the encoder learns what features matter and the decoder rebuilds the image with more clarity. Inside the tiny model. Our model is called tiny because it is simple and light. It avoids huge networks like ResNet or GANs. It is built using basic CNN layer, Con 2D layer. These understand edges, shapeness, and textures in the image. Max pooling 2D. This reduces the image size, which makes the model faster and help in understanding bigger patterns. Upsampling 2D. This does the opposite. It increases the resolution, allowing us to rebuild a clear image. So the idea is first compress the image, then learn feature, then rebuild it. Implementation the encoder. In the encoder, we define the input shape using keras. We then use convolution layer to detect image features like corners or lines. After that, we apply max pooling 2D to reduce the size. For example, a 256 cross 256 images becomes 128 cross 128. This compression helps us keep important information while removing noise. Implementation the decoder. The decoder does the opposite of the encoder. We apply upsampling 2D to increase the size of the image again. This helps us to recover the resolution. Finally, we use a last layer with three filters, one for each RGB color channel to produce the final high resolution image. The model learns to fill in lost details during training. The result. After training the model on many example images such as faces or cars, it learns to remove pixelation. We use two main metrics to measure how well our model performs. Mean squared error MSE. It measures how close our prediction is to the original image. PSNR, peak signal to noise ratio. A high PSNR means better image quality. On the example shown here, the left image is low resolution and the right image is that the model predicted. You can see the model makes the blurry image look more clear and detailed. Image sources. These are the sources of the image used in this presentation. All visuals come from online platforms and are credited properly. Thank you for watching. In this short talk, we learned that image resolution is why is important and how a simple CNN based autoencoder can improve image quality. This technology is widely used today in photography, medical imaging, security, and even old video resolution. I hope this presentation was easy to understand. Feel free to ask any questions. Thank you.